So DDF is a format developed by my former colleague Jasper Hever, together with Gorka Zeng, Ole Rosling, and there were 3 developers from the company Valor Software in Ukraine who have also helped us to develop this data format. The documentation is available through the link here. So, an introduction to the DDF, the universe, the formats, DDF CSV, and so on. So I won't go deep into the documentations, but it's just a link so that you know where to find further reference about the format. So what is the idea? DDF is a data model for collaborative harmonization of multidimensional statistics. Yeah. Let's unpack that. So data model means it describes way to organize the data and define how different pieces are related together. It doesn't define the exact format that you're supposed to have your data in. So if I go and look at this GitHub dataset, then every file here, let's take one of the files, is a CSV file, yeah, comma separated values. And all the other files, like let's say evaluation, oh, that's too large. It cannot show it. Another file it's again a CSV file, yes. So and each of them files is tidy data CSV here. They don't have to be. And this is the thing about DDF, it's a data description format, it's not a data storage format. So that means that it is agnostic to the actual way you store your data. So you could have these data tables somewhere like in SQL database. You could have them in JSON files. You could have them in Excel files, whatever. Then what does DDF do? DDF describes how do you organize these separate files or these separate data tables and how they should be related to each other. So the description, the data description format or data definition format is about organizing your information in these different categories of different files. As you can see, there is 3 categories that you can see from the file names. There is concepts, data points, and entities. So now we'll get to each of them different types of data tables. And to do that, I have prepared a little presentation that would show Gapminder bubble chart and at the same time show the data that goes behind the bubble chart. And that would illustrate the idea behind these different data tables that we have in DDF. Okay? So, like I mentioned, concepts, data points, and entities. Let's start with the data points, because that's the easiest one to understand. Here's data points, example of data points table. That's the one that you have for your AI experiment. Here's model configuration, prompt variation, and correct rate. So this is a data table, only 3 columns. And each row here is a data point, and the data file is called data points. So if you would store this in SQL database, you would have something like data points, correct rate by model configuration, prompt variation, table in your SQL database or whatever. So this name here is constructed descriptively. So first it tells us what kind of data file it is, it's data points. Then it shows us the measures. Here it's only one measure, correct rate. And here it shows by. So by is a separator that tells us that the next parts is the dimensions. The dimensions here are model configuration and prompt variation. Yeah. Back to this example, we've seen that a million of times. Here our dimensions are country and year, and here we have 3 measures that depend on country and year. So when we have this data table, it's very easy. It's a tidy data table, And you can make this kind of chart based on this data table. So you filter them by a certain year. Here it's 2015, and you show all the countries. Here is all the countries, and here I can filter it to show me a different year. Yeah, simple. So you encode different X with GDP per capita, Y with life expectancy, size with population. And look, your axis titles, they are called exactly as they're called here in the file. So life underscore expectancy, and here's life expectancy also with underscore. So, and then that configuration may go to the URL and stuff. So then you're not allowed to have spaces and like capital letters. They're not so nice because computers don't like formatted text. And then you can't have like multiple languages. If you want to translate that to Japanese, Chinese, Arabic, whatever, then you can't have translations in it because you have only like one column or one column header. You cannot have any description of what life expectancy actually means because, again, you just have one column header title for it, so that's very limited. We don't have any colors. Here color is a constant single color, so we can set that, of course, to our maybe life expectancy, but that's it. We cannot join a different like regions table to this thing, yeah? So, and then our country names, they're also like, look at Ukraine. Poor Ukraine has a 3-letter country code, and China has a 3-letter country code, and USA has only 3-letter country code. So that's quite boring, yeah? So what is the next step that we do? I don't remember. Hey, let's add another data table so that we can switch between different indicators or like different measures. So when we join this data table to this data table, it's very easy because they have the same exact dimensions, both 2 dimensionals, and the dimensions are country time. So then we can change that to CO2 per capita, and now we have Y to CO2 per capita. Okay, cool. Next step. Let's look at the entities. Now we add another type of data table. So we now looked at data points, and now we're looking at entities. So what are the entities? The entities, they are basically dictionaries that tell us what things are and what kind of properties they have. So for questions in your AI study dataset, we would have something like question number, and here is a published version of a question. Yeah, pretty good. And then you actually can read the question here. And then what else do we have? This is not very convenient because I need to scroll all the way down to get the scroll bar here. But I have a topic of that question. I have some answer options, like so, and let's scroll up again. Now that's ugly. So I have some answer options, like, and I have a short version of the question. So here's the answer options, and here's like which one is correct, which one is wrong, which one is very wrong answers. Yeah, so, and back in our entities file here with countries and, yeah, just countries. Entities, they are by necessity one-dimensional. And the only dimension we have here is the 3-letter country code. So at this point, we can give them names, which are like human readable and nice names with capital letters and spaces in them. We can give them world regions, we can give them latitude, longitude, and so on. So like these are properties of different countries. So that allows us to set colors by different regions, because we have regions here. And look, the regions themselves, they don't have capital letters just yet. So for that we need another data table. But for now they just like region codes. But we can have colors already. And if we hover our countries, you see how our country codes, they have now got their names properly. So we are building this step by step. And now we didn't like that our regions didn't have names, so we add another entity file with world regions. And then we list them regions, and then we also give them names. And then we can also give them shapes so that we can make this kind of nicer map, world map, and then they have names with capital letters in them. All right, next stage. So that goes, I don't remember which kind of example this was for, but this looks a bit more complicated. I don't know. The final type of the table here is called concepts. So let's look at, again, concepts from the AI study dataset. The purpose of that file, the concepts, is to list all your columns from other data tables and describe what these columns mean. So here I would have question. Remember we had question column somewhere. There it is. So it would be it would be named question. Its type is entity domain, and do I get the scroll bar? No, that's it. That's the whole table. It has very few columns. But here, imagine that here I have my country, year, life expectancy, and so on. My names here can be like nice human readable names with spaces and capital letters in them. So this is what allows us to write nicer names on axes. So now I have life expectancy years. Remember, in the previous one, we could only have life underscore expectancy like this. And now we have a nice name, and we give it a unit, and then we can give them descriptions. The average number of years a newborn child would live, so the description can go in here. And we can also set preference to the scales, such as life expectancy is only allowed to have a linear scale. So there's no option here to set logarithmic, but GDP per capita can be either logarithmic or linear. That's how you have a selector here. And it prefers logarithmic because it goes first here in this array. So that's how the GDP per capita starts, the chart starts, and it chooses the logarithmic scale because this concept property scales tells the chart that it prefers to be logarithmic. And then, of course, like we're only discussing the data format now. After that, you can code whatever custom logic that you have to interpret the DDF dataset, and that custom logic is responsible for choosing the scale to start with. Yeah. Cool. So now we have the chart that you usually see normally. So then that's it. This is basic DDF, and now you know how to interpret this data set and how to understand the different files in here for the homework. However, I would like to now highlight a few of the features that DDF provides, and this is like why we had to develop our own data format instead of using data formats that already are available out there. So I would like to introduce you a few of the features in the DDF that make it so cool. So the first feature I would like to introduce is called entity sets. So we not just have entities, but we can group them into sets. So what I mean by that? This allows me to say that some of them countries or geographic locations are countries. Some of them are United Nations states, like United Nations members and permanent observers of the UN. Some of them are cities. So then I can have multiple geographic locations in my dataset, like Sweden, Taiwan, Singapore, Stockholm, and so on. And I can classify them here to be countries or cities and so on. Because you see, I could have like data let's say population, I can have that by countries, I can have that by cities, and so on. And then I could resolve all the ambiguous situations, such as, is Taiwan a country? Or Taiwan is not a country? Because if I say Taiwan is a country, then the Chinese government would not like me. And then whatever charts I make, 1.4 billion people will not be able to see them. Yeah, because they will ban the charts. However, if I set Taiwan, it's not a UN state, so I can show on the picture I can show UN states. And if I make an option for the user to switch UN states to countries, then I get Taiwan back into the picture. Yeah. So this is the way to resolve these kind of ambiguities. At the same time, Singapore is both a country, a UN state, and a city. So that's weird. You know, Vatican also a country and a city. And then if I show like, well, Singapore is quite large, right? So if I show biggest cities in the world, and I want to show their air pollution data, then my Singapore would end up in that data set. And if I show population of countries, then Singapore would also end up in that data set. So this allows Singapore to be participant in multiple entity sets. Yeah, so all of, and here's how they are reflected in the concepts. So my geographic locations is an entity domain, and then on that entity domain, geo, you see it here, I define 3 entity sets, namely the countries, UN states, and cities. Yeah. Here I have a little Venn diagram that explains how Singapore here is both a country, a UN state, and a city. Here I have Malay in Maldives, which is a city. It's not male. See? For that, I need another entity domain of gender. Let's say I have male here, and I have male in a different place, and I would have that in a different entity domain. That's why I need different entity domains for those things. Stockholm here, and Sweden is both again a country, an entity, and UN state, but not a city. And then Taiwan is a country, but not a UN state. And Pacific is neither of each of them. But it is still a geography. Yep, so then I can set their entity properties like so, and I can define my data points just normally like I do in every other file. And then I can use this idea of entity sets to filter my charts and show or hide different geographies. Here I have an example of 2 bubble charts. If you look at them carefully, you can see that this one has only the UN states. So we have USA, Germany, Japan, and so on. This one has a white bubble here that the other chart doesn't have. It's world, because this one shows geographies. So I have a world geography in my data set. But this one is configured to not show it, this one is configured to show it. And because it shows all the geographies, I also have Taiwan here. But I don't have Taiwan in the other chart. So that's how that is solved. All right. Next feature, multidimensionality. And we've discussed that many times in the course. So this is just like a 1-minute repetition. My data point files, they can have country, year, population, country, year, age, population, country, age, gender, population, and so on. So I have separate data tables for separate dimensionalities. And that's how I can feed my chart with data by country, year, age. That is what you see here. Or I can switch to them 2 sides, and that's how I have country, year, age, gender. So population by those 4 dimensions. So in practice, like in the code, that means that I just switch the chart from one data table to another data table. And those data tables are prepared in the data set with these dimensions going in the columns going in there. So that's multidimensionality. And this is an example how it may look like in practice. Here I have, and to make it cool, I'll restart the page, because there's like a little animation of South Africa blown up into provinces. And then there's like people migrating between different provinces of South Africa. So here I can hover different provinces and see where people go. So if I hover Western Cape, then the green arrows is people migrating into the province, and the red arrows would be people migrating out of the province. Yeah, a lot of people go to the capital region, Gauteng here. But I can also slice and dice that data cube because it's multidimensional, right? So I can have, for example, I can only show black Africans, and the migration pattern is very similar. Or I can show white people, and white people, they all go to Western Cape. That's like the whitest and the richest of the areas of South Africa. I can show total again, and I show male and female, and I can see that there's not a lot of distinction here. And I can show age groups here as well. So I can see where the youth is going. They all go here to make money. And the elderly, see that pattern then reversed. So youth go here from the northern provinces, and elderly, they go back because they made their money, now they go back home to die. So that's what they do. So here is the practical implementation, and you can only see like youth, female, and then white, yeah, for example. So you can slice that to show you this specific data point between different provinces. So this is like from, to, population group, sex, age group. This is 5-dimensional data. Yeah. Speaking of flexibility that dimensionality gives you when making charts. And final feature of DDF I wanted to show you is translations, because this structure of the files now allows me to also add different languages in my different, let's say, names of concepts and so on. So in my translations, I can just declare that I also want an Arabic language, and my Arabic names for like life expectancy and GDP per capita and the descriptions, they would all look like this. And then my entities, they would be translated like that. So then I have my regular entities file in English, and I have a translation in a separate folder in the same data set. So then the same files could also be translated to different other languages. And then practically, that would mean that I have my tool here, which I can switch to Arabic language. And then all the country names become Arabic, and all the GDP and life expectancy labels, they also become Arabic. And if I click here, then the entire data set is fully Arabic, see? But also like the user interface is now right to left, because that's like a different way, different directions you read that language. That's it. These are the features I'm showing you in the data description format. Again, the reference to documentation is here. Open numbers, github.io/DDF. And hopefully that sets you up with successful doing the assignment.